1, 2, 4, 5.
Hello my friends and welcome back to Petrol Garage. On popular demand, I've been asked to do a little bit of a video, not how to, but how I am porting, because telling the world how to, I might regret it. So let's just say how I'm porting and how I'm trying to succeed in finding power or wide power band or whatever it is. But beware, I'm not good at mediocre porting. It's just race porting all over. But I find it like the engine should always be good flowing and held back on durations if possible. So then you can adjust the power band a lot with selecting the tune of your pipe. So many of my porting is actually working with softer setups. So I'm about to start working on my TZR 250 engine again, and I have resleeved the cylinders and started working on that. They aren't finally bored yet. 56mm is the bore I'm gonna use, standard, but now I have saved 1mm, so it's 55 in the bore right now, 55.2 actually. So I saved 0.8mm to the final bore after I've done porting it. So thereby it isn't any big risk of making damage if I'm slipping beside the ports and making marks and all that. I'm going for a little bit of a change in porting. I'm going for larger B transfers and smaller boost port. As I've learned from the big guys, as if there are somewhere you want to port in a cylinder, it is the B ports you want to increase the flow. And looking at modern cylinders, I've seen that, yeah, that's the direction it tends to go. So, where to start? Let's just concentrate in this episode on exhaust port. Yeah, I'll show you a little bit. This is the engine then. It's used pistons. They have turned down to 55.1mm, so kind of sloppy, but they're good to use to scribe up in the ports, where you can put on some more light, maybe you can see the ports a little bit. This is very roughly ported right now, and a little bit of a hone job also to make it slide a little bit better, and also paint onto a little bit easier. And you got the exhaust port down there. It's a three port design, and yeah, I thought I'd show you a little bit about how I'm doing it. So I'll set up the camera a little bit different and try to get some light and show you. So I'll pause a little bit. So we're back there, back here, back everywhere. So how I'm doing it then. 100% wide exhaust port is, of course, I'm only sketching now and not measuring anything, is about there to there, and then a straight line all over, all across. Let's see if I can get something. This a little bit. This one will not be exact, but it is for showing purposes only. Let's say this is the middle of the piston, a little bit crooked, of course. This is 100 This is a good full race width of a 3-port design, but you might not want to use that if you're going to run it as a street bike, or otherwise you might also need to plug the holes for the wrist pin. In race application, drag racing and such, you can run without plugging it. It's an over-exaggerated, or how to pronounce that, cause of error, so to speak. They run just as good, almost just as good. In peak power, no issues. But I often put it at about 92 to 94%. That is about there and there in width. So and then the main exhaust is about right there and right there, somewhere, maybe a little bit smaller. And let's see, this is the I'll write a little bit crooked, so let's paint it like this. This is the, and then it turns and goes into the exhaust duct. Important thing is to, from center of piston, when you're porting out into the sleeve and into the aluminium, is to follow the path like this, is to follow this path the center of the piston aims towards the edge of the exhaust port, and here you follow that path and then makes as huge as you can radius. I cannot show you how, into the, to get a turn into the exhaust duct, and this let's see, where am I? Right there somewhere. It should also follow that path to the main exhaust, and you can make it a little bit of it's very wide marking right there. You can make that also a little bit of a turn, because let's say you're following the cycles now, about there before top dead center, blam, and the piston goes up, and then piston goes down, and main exhaust is opening first. Blowdown is happening. It's called blowdown. No, not blowdown. Maybe it's called blowdown. The blowdown area, you need to make always as huge blowdown area as possible. That's the width I'm talking about. But blowdown duration time is about this, and the main exhaust opens, let's say 5-10 degrees before auxiliary exhaust. This is, from what I've read up on and got explained to me, it is the main pulse when you got the most pressure in the cylinder. When it opens the main exhaust a couple of millimeters, there's the pulse happening, and then the piston is traveling more downwards, and the auxiliary port is to get the rest bulk flow out of the port, no, not out of the cylinder, before, to lower the pressure as far as you can, hopefully below crankcase pressure, so the transfers can flow freely when they are opening, without having exhaust gas recirculation into the to the crankcase. But if you're having that, the first degrees of transfers will not flow in correct direction. It goes exhaust into it, heats the cylinder, and then goes back, and you got chaos. But let's focus on the exhaust. The exhaust duct. These cylinders are quite good. It is quite a small exhaust duct. I don't know if you can see. Can you see it? It's, yeah, you can see a little bit. I can measure it for you guys. Diameter of these are about 34 millimeters, and this is good. Do not port it too large, because you want the high velocity to make use of speed to charge the pipes and let the pipe charge the cylinder back. And then a thing I often do is the top edge of the port. Be careful how I'm what direction I'm pointing now. I always talks about a radius on the top of the exhaust port. It's not this radius. Over exaggerate. It is this radius. I'm porting the radius about like a radius 2, like a 4mm drill or something, to get more flow from the same duration, and thereby you do not need to go as high in duration, and by that saves some trapped volume to compress. You're achieving higher VE numbers, volumetric efficiency, by that, and it's a freebie. Actually, you can get, because it's what it's all about anyway. It isn't timings. Yes, you need timing, but if you're having a very efficient exhaust port, you do not need as much timing as the lower efficient port, and thereby you gain wider power band and still containing saving the high RPMs need for duration time. That is a little bit about exhaust. I will paint up a picture later in the video to show you a little bit better. But now I'll take the other piston and show you a little bit about the transfers. This is a little bit harder. I'll go down and mark up a little bit where my transfer is sitting at the point while you're looking. This isn't the final shape. I'm just for your viewing pleasure. I'll start. Let's have the center of the cylinders right there, and I say you should aim all ports somewhere in this region. So front of the now it's this port is sitting right here, but I will port them more downwards, but now they are right here. And then you should aim about this, and the rearmost, not to the same point, but aim like there. Because aiming to the same point, you get very turbulent flow onto the piston. And these ones, front wall of the transfers, B transfers, you can aim them. I'm making a very odd shaped line towards each other, and then you got like so, and this is the rearmost wall, but you can make this, I call this a hook, and the port, and the same on the other side also. Where is it? Right there. Yeah. But in this corner, do not make that sharp. Be sure to make it round with the radius. Making it sharp creates unnecessary turbulent flow, and you do not want that. And then the boost, like this, it will be thinner, like this actually, just 1 or 2 millimeters between the ports. This one is aimed just straight into this area. And then the timings on these ports. A is, by my porting experience, also the Aprilia RSA had the same, has got lower timings than the B ports. B. The B has about the same as C. And by that, when the piston moves down, and it opens right there, and then you start to flow in the rearmost area of the cylinder, and it starts to move upwards while the piston is moving downwards, of course, and the flow wants to, in the head, turn around down into the exhaust. This is happening fast, and then the A ports are opening with a new angularity, a little bit more upwards than the B ports, to help the gases that come from B port and C port are turning over, and the A port is, when it's open later, is trying to push it back again, like pushing it back, and then the piston turns around and closes it, and hopefully you have trapped a lot of fresh gases if the angularity is correct. This is what the big guys are calling leaning Tower of Pisa, in the flow column of air that's moving upwards. You need to, as the picture of many tourists are holding the tower so it doesn't fall. It's like that process. That's the, let's say, B port's timing. Let's say I've got 198, 200 in exhaust. It's high durations, yes. This one I aim for 13,000 now, peak power. And then you got the blowdown area. Try to get that above 30 degrees. 30 times 2 is 60. So let's say you got 200 degrees. The most transfer timing is by that 140. 140, 200 minus 140 is 60, divided by 2, 30. And then you got 30 degree of blow down area, blow down timing area. If having lower than that, you probably start to get exhaust pressure into, let's say you got 200 degrees and then 145 degrees on transfer. Very odd. You will probably never have that. But then you got too little time to get the exhaust out of the cylinder. So when the pistons open in the transfers, you still got somewhat high pressure in the exhaust port, in the cylinder, that pushes down into the transfers, and the flow in the transfer is and then when the piston moves and more pressure is relieved from the exhaust, it comes up again. But now with in the gas front, you got a heated zone that is trapped into the cylinder, making bad combustion, and actually not bad combustion, it can help combustion, but it's not as a pure charge that is moving up and get trapped in the cylinder to get burned and then all over again. So that's a little bit of how I'm thinking porting. We'll aim about this one between 198 and 200 degrees, and 136, 138 maybe on the B transfers, and then A transfers about 132, and B transfers is aimed about 7 to 11 degrees. This is in bottom dead center now. Ignore that it is in top dead center. It's flowing, hitting the piston, thereby cooling the piston also. And the A transfer later on is aimed about 22, 25 degrees upwards to achieve that leaning tower pizza effect. Boost C transfer, boost port. I have good experience. Not many, when porting them, are aiming for the spark plug, the center of the tändstift, the Swedish tändstift, the center of the cylinder where the spark plug is. I'll say you should aim it more in front. With a kind of a little bit of a hook in the boost also. I will be back on the hook. I'll say aim about there. The piston's about 10 mm down in the bore, and so about the half stroke from exhaust to top dead center, about in the middle. Aim it, the hook right there, and now to the hook. You get that when the piston open, you got a flow a little bit that hitting the crown of the piston together with the B transfers, and then it's this first little millimeter that flows, you got very high speed on the gas stream. It kind of like flows above the piston, is my take on it. I don't know if this is for sure, but I think it works like this. And then when it opens a little bit more, it starts to flow more upwards, because more of the port is opened, and the main area of the port is flowing like in this area, a little bit in front of the, not right here, a little bit in front of the spark plug to the exhaust. And then when the piston goes down and when it opens, the piston now, when you got suction in the pipe, it sucks right here right now. You got that flow hitting again when you got a big column of air moving upwards. You got that a little bit of extra flow before the port closes that is flowing again over the crown. But this is very slow flow, as there aren't that much energy. There are energy, yes, but not as much as when the crankcase compression is helping the pipe suck also. And then just moments later, this goes fast, moments later the returning plug pulse from the pipe is shutting the exhaust closed. And also before shutting it closed with pressure, it has sucked out too much charge, and it's pushing it back to some extent into the cylinder, and then the exhaust closes totally, and you hopefully trapped a lot of fresh gases, making for way above 100% VE. On top of my head now I can't remember, but 120, 122% VE, maybe more. Someone correct me. But having that working, it just sprinkles power from the engine. It just becomes insane. This configuration on methanol, not this configuration, but this cylinders and this engine on methanol with electrons, it has 96 to the wheel, and it isn't perfectly, it could do more, but I'm only one guy in my little garage that's testing things. I haven't got the whole developing team that builds pipe, like 20 pipes a day and cast cylinder 20 with different variations per day, and all that. I got these cylinders and I got this engine. I'm trying stuff and I'm going back on stuff. I'm trying stuff, and it takes time. And if having that big budget as the big guys had, it will of course mirror down to having bigger power. But I think 96 to the wheel is quite good anyway, on methanol of course. Now I've taken the challenge. I will probably not reach it, but my goal now is to find about the same power on petrol. Yes, I will just raise petrol 108. Yes, camera died. Where were I? I'll try to achieve the same power on petrol, and this will be about the first part in my porting. I've talked a little bit about aiming in the radial plane and then the horizontal plane, exhaust and everything. Exhaust has also quite an important angle. I think it is about 25 degrees downwards, but it is what it is if you aren't having that. So with that, was a little bit of a talking video. I'll start porting this, but not today. Yes, and to continue, I have, as I promised earlier in the video, can you see anything? Yes, you can't see me, you just can see my hands, it's good enough. However, I just draw a quick sketch. There's nothing perfect in this sketch, so don't hang me on the wall of that, on that issue. Cylinder, main exhaust, auxiliary exhaust, A transfers, B transfers and C transfer. Main, X, aux, A, B, and C. So, to repeat a little bit what I was talking about, how I'm doing things, and once again, this is not how you should do it. I'm not forcing you to do it like this. This is how I'm doing it. I'm not saying this is how it should be done. So this is a little bit copied from Aprilia RSA. Yes, it's the Holy Grail, but you need to revert a little bit. In my case, I haven't got a square engine, as I got 56 bore and 50 stroke. Aprilia RSA has got 54 bore and 54.5 stroke. Thereby I lose a little bit time area in bottom dead center, as my piston is moving faster with a shorter stroke in the end bottom dead center. I could compensate it with a longer rod, and I have longer rod in this. This is equipped original with 105 millimeter, 105. I've got 110 millimeters from RD 350, just as a cool notice. So let's start. Main exhaust area. Width, I haven't written down anything, but about 65 to 70% wide of a bore, cylinder bore. And then auxiliary exhaust, in my case about 94% of cylinder bore, and then as wide here as you feel safe. The thinner, the more heat. So if I go on by a street application, a non-alcohol engine, I would say larger. Going hard on drag racing or alcohol engines, you can make this thinner, as the exhausts are colder. Let's see what I said right there. Approx 25, yes. However, let's A transfers then. Aimed the front wall, aimed about this area. It's crooked right here, but the front wall aimed about that, and the rearmost wall nearest to the B transfer aimed right there about. Let's say this width almost the same. It could be a conical shape a little bit, but not too much. And then B transfers, forward wall, the foremost, what do we call it, the most wall nearest to the exhaust, those one can be aimed straight 180 degrees, straight to each other. I won't write the line now, but like this. You can do that. You can angle it a little bit backwards also, but I'm doing it like this. And then the rearmost nearest boost, C transfer, is good doing a hook right here, but do not do like this, a sharp edge. That kills flow immediately, and you got dead area inside here, and you get turbulent flow, and you do not use the whole port for flow, as there becomes eddies and things. And you do want a nice rounded shape to get the flow to smoothly follow. And then aim that one into about the same area as the rearmost wall on the A transfer, about right there. And C transfer, as wide as you think you can allow. B transfers are the ones that gives you the most power when porting a cylinder, as it is most far away from the exhaust and flows well, and the flow that comes together will automatically travel upwards, and then get help also by the C transfer. This is about the flow directions I wanted to show you on the paper, a little bit more easy to view than this inside the cylinder. And in my case then, where am I now when I haven't ported it? I just have hogged it out to use a smaller tool now to be able to fine port it. So there aren't any pretty things at all, it just hogged out. So TZR250 in my case. I got 50mm stroke, 110mm rod. This is where I am right now, in port heights. And what does that equal out to? As now I've got 191.7 exhaust duration, the same on auxiliary ports, these two, these three, so now it's the same now. And then air transfer is 131.8. I'm guessing it's, I'm just bad writer. And B transfer 134.6, and the same as C 134.6. Of course, that's the same numbers right there. And what am I aiming for then? This. I'm aiming for a 26.5mm from bottom to center high exhaust port, main, auxiliary, the two on the sides. I'm aiming for 25mm high ports. A transfer, I'm already at this point. I'm a bit lucky right there. I'm a bit lucky. Aprilia had a little bit, not the same number, but a little bit lower duration. And I'm also close right here, 12.9, I got 13, and 12.9, I got 13. And what I'm aiming for in duration, no, I got 12.9 and aim for 13. I got 1/10 of millimeter to adjust, and also in the C port. And I'm aiming for 200 in main exhaust, as I wanted to rev 13,000, set peak at 13,000 RPM. And auxiliary transfers, no, transfer exhaust, 193. This isn't set in stone, but it's what I'm aiming for at this point. And front A-port, 132. Aprilia RSA had 130, if I remember correctly. And they had 132 on the B port and C ports. I'm aiming for 135. Actually, I don't remember if they got the same, but I'm aiming for the same. That gives me, in this case, 200 minus 135. I got 65. That's 32.5 in blowdown time. And that's good. A little bit above 30 degrees. And keep in mind, try to at least 30 degree, not below it. Keep it above it. If it is possible for you. Because having 28, 29, the engine becomes very, very, very peaky and very, you not blow down, you blow out so many, no, you get so much exhaust down into the transfers. So the engine becomes very overheated, and it doesn't want to pull into the pipe. It's just blurbing, and then when it pulls, yes, it pulls, but area before the pipe pulls, it gets about almost zero power. So try to get a little bit above that. And this time I'm aiming for petrol, about 108 to 110 octane. That gives me what I should aim for, about 15 to 1 in compression, total compression ratio, and about 48% area squish, with about 0.8, 0.7 in gap. About that. Well, whatever, that ain't porting. In my case now, this is the old reeds. I have bought new reeds. Those are a little bit wider, as you can see, about 10 millimeters wider actually. So I need to modify the engine, and then It's missing reed plates now because I have measured them. And I use Polini blades as they can take a lot of fuel, and they are a little bit stiffer on the same thickness as B4's original. So 3D printed this adapter. It can take those cages now, and I can use the same intake manifolds up onto those. I just port them out. These are made for 39mm carbs. And now I have 3D printed new stuffers. I need to port them a little bit, and I'm aiming for running 40 carburetors. So that's that. Yes. Oh, that's very bright. Wait. So, yes. So. That's a little bit about porting. I'll show you in next episode a little bit about the tools I'm using and a little bit how I'm doing it. But I got this issue with my arms, so I can't port for more than an hour. Then I'm waiting. It's called carpal tunnel syndrome. I'm waiting for they'll cut me open and fix that issue in both hands. However, where am I? Oh yes, the Syndap. I said in the episode I just recently released, it would be the last one. But I'm feeling it, the engine is so lazy underneath, let's say 4,000 or 5,000 RPM. It's almost undrivable. Coming to a small uphill, I need to shift down. It can't. It's just bogus. A lot of power with piston port is what it is. So I'm going reed, but not that small reed. I will modify the cylinder, I will mill some, and I'll try to get a larger reed into, not try, I will get a larger reed into it, and make some nice Boysen port, and try to get the crankcase to breathe properly, and shoot good amount of gas through the C ports. There are double C ports in that one. But that will take some time. It will become an update a little bit in every episode, maybe, while I'm porting this, how I'll be doing it. My cogs are turning right now, how I'm supposed to fit a larger reed than you got space for between the studs. I got some ideas. And I do not want to weld into the cylinder, because I do not want to distort the bore. So, yeah, I got some ideas I will present to you later, in a later episode. And then I need to mill or cut off from another cylinder a reed cage. But that's in the future, so look forward to that. And this is a little bit about porting, long episode maybe, and it will be a little bit more. So I'll see you in the next one, guys. Bye!